it. So last day of new notes. This is Friday, January 12th. Monday's a holiday. Yay for us. Tuesday is hopefully not a holiday. Review. And then Wednesday and Thursday, it's not block day. It's a 2-part test. We'll test. That's the current plan. If something crazy happens weather-wise and school's canceled on Tuesday, then Wednesday would be review. So this is the alternate plan. So if it gets canceled, then Wednesday would be review, and then Thursday, Friday would be the test. And then I'd have to figure out what we do after that. So there's the plan either way, school or no school on Tuesday. All right, integrals yielding inverse trig functions. Well, let's back up. If f of x is arcsine of x over 2, what is f prime? So this is a derivative question. So again, you always got to be careful. Are we finding a derivative? Are we finding an antiderivative? This is derivative, which I guess is good because we don't know how to do an antiderivative of that thing. Okay, arcsine. That's the one that's 1 over, because they're all 1 over. Tangent doesn't have the square root. Sine and secant have the square root. It's me trying to think through the options here. Secant has the absolute value also there. Sine doesn't have that. And so the last thing is it 1 minus argument squared, or is it argument squared minus 1? Do you remember which one it is? It's 1 minus. Sine gives you small values, so you do 1 minus the small values. Secant gives you big values, so you do argument minus 1. That's how I remember it. So arcsine is 1 minus argument squared, and then don't forget the chain rule, times 1/2. Okay, if we were safe stopping, we would box that up and call it a day and be good. But I want to keep going because this is going to help us get to what we're headed for today. So let's do the algebra here. So 2's in the bottom, square root of 1 minus x squared over 4. Let's see. There's a couple ways to do the next algebra step. You could get a common denominator in here and then square root the 4 in the bottom. What I think I'm going to do, I don't know, neither one of them is particularly easy. I'm going to distribute that 2 into the square root. But I can't do that right now because it's not a square root. So how could I rewrite 2 as a square root so that I could multiply them? I could rewrite this 2 as the square root of 4. It's like, well, why would you do that? Except that I can peek ahead and see that 4 would be helpful to cancel that 4. So if I distribute that, right, they're both under the square root, so I can multiply that 4 into there now. I'd get 4 minus x squared. Again, on your own, you wouldn't do that. Like, right, if you asked for the derivative, you'd stop here and be like, thanks, I'm good. But if we get to, well, let's back up. So the derivative of the arcsine of x over 2 is 1 over square root of 4 minus x squared. That's the answer to what we just did without all the steps thrown in there. This means that the antiderivative of that thing, well, if the derivative of this gives me this, then if I antiderivative that, I get back to arcsine of x over 2 plus c. Okay, well, let's see if we can follow this pattern here. I guess the big thing is that thing right there. if I'm looking at this one, square root of something minus x squared, that looks like arcsine. And if I kind of follow my pattern, the arcsine of what? What do you think? 3. Arcsine of x over 3. And then plus c. All right, well, what about the next one? That's not quite as nice there. It still looks like an arcsine because it's a square root in the bottom. It's something minus x squared. So it's definitely arcsine of x over square root of 7. All right, it doesn't have a nice answer, but square root of 7 plus c. Okay, well then more generically, let's keep following this pattern here. Again, it looks like arcsine because it's a square root in the bottom. It's an x squared down there, so arcsine of x over a plus c. So that sort of leads to our rule here. A squared minus u squared in the bottom, that looks like arcsine, where the argument is u and that denominator is a plus c. So this first starred box, that's exactly what we just did. So that one's easy. That's arcsine u over a plus c. Ooh, be careful. U a. Now we could go through that same process again and again, but I don't want to take the time to do all that. What does this next one look like? You know enough to kind of get in the ballpark. It looks like arctangent. So you're right. Be careful when you write this. Leave a little space out front because arctan's a little different. It's also u over a. But there's kind of a chain rule thing that's going on, and you get a 1 over a out front. The arcsine doesn't have that. The tangent does. This next one looks like arcsecant. It's also the only option left. It also has a 1 over a out front. Arcsecant u over a. And this one gets an absolute value on there. Finally, a little bit of good news. Integrals yielding arcsecant are not tested on the AP exam. So, it is on this test, but this is one of those, yeah, use it and forget it. Everything else you got to keep remembering, but this one, not as much. Okay, so number 1. Well, what does it look like? I mean, don't even look up here yet. Think back to what we did yesterday. Like, again, the best way to do antiderivatives is to know your derivatives really well. So what derivative does that look like? See, it's not arcsine, right? It's not tangent. The square root means it's either sine or secant, but there's not a number out front, so it's definitely going to be an arcsine thing. We haven't dealt with this before, so let's. We really want that to be a squared minus u squared, right? We want that to be a squared minus u squared. So that means a is 5. That's the easy part there. What does u need to equal then? If I want u squared to be 4x squared, that means u needs to be 2x. And then du needs to be 2dx. So here we go with spawning numbers again to make things work. So I can put a 2 there and a 1/2 out front. So I've got 1/2 du over square root of a squared minus u squared. Now that definitely looks like arcsine. That is arcsine. So 1/2 goes to the 1/2 from out front. Arcsine of u over a plus c. And you can even leave it like that because you've told me what u is and you've told me what a is. So you can leave that. What's number 2 look like? See, there's no square roots, so pretty sure we're headed for an arctangent answer here. Arctangent needs u squared plus a squared in the bottom. So u is equal to x, so that's nice. I don't have to worry about du and spawning stuff. That means a needs to be square root of 2. That 3 we can just move out front. Like that. What is he doing there? Just get him out of the way. So arctan of x over square root of 2. But arctan has that extra a out front. So that looks kind of bad now. 3 over square root of 2. Arctan x over square root of 2 plus c. Silly, but this is how I remember the arctan is the one that has an a in it. So that's the one that has an extra a out front. There's just a's everywhere for arctan. Secant does too, but we don't really worry about secant so much. So let's see. What does number 3 look like? Like big picture, this is where we have to kind of start recognizing things. Big picture, what does it look like? Arctan, arcsine, or arcsecant? Why arctangent? I agree with you. Okay, that's one part of the answer, at plus sign, and there's no square root. So pretty sure this is arctan. So we need to kind of recognize where we're headed. And we know arctan is a squared plus u squared in the denominator. Now I got a sign in the top, so something weird may be going on. A is square root of 7. That's easy because I don't have to do anything else with that. U needs to be cosine. So du is negative sign. So we can put a negative in there. And that's du. Negative out front. 1 over a squared plus u squared. So that's definitely arctan. I think we usually had the u squared first, but it doesn't matter because they're added. So arctan of u over a with a 1 over a out front. And I can leave that as long as I've said what u is. Yep. And what a is. So yeah, I'm just going to leave that as my answer. It's okay to leave that. Multiple choice is going to plug those back in. What does number 4 look like? Arc. It's got a square root. So, but there's not an x out front. So I think this is arcsine is where we're headed. Arcsine has a squared minus u squared. That x in the top looks funny, but let's see what happens. So that means a needs to be 3. It's the easy part. What does u need to be? I want u squared to be x squared. Well, I can actually just start there. I want u squared, not x squared. I want u squared to be x to the 4th. So that means u is x squared. So that when I square the x squared, that's where the x to the 4th comes from. This also fits because that means du is 2x dx, which is almost what we have in the top. So 1/2 antiderivative du over the square root of a squared minus u squared. That is definitely arcsine. So these are tricky because you basically have to recognize at the outset where you're headed, then work out the details, and then come back to the fact that yes, this is an arcsine problem. So arcsine of u over a. Sine does not have the 1 over a out front, although that 1/2 is still out front. Plus c. And if I've clearly said what u is and what a is, then I'm okay with this answer. Again, you've got to know your derivatives well enough to recognize right away what's going on so that you can kind of work toward it and get the details out. How about number 5? What does number 5 look like? Well, that's tricky because that x out front makes you think arcsecant. But arcsecant is like argument squared minus 1, and this is backwards from that. So it kind of looks like arcsecant because of the x. I'll grant you that. But that natural log of x in there, let's see, if a is 1, u is natural log x, what's the derivative of natural log of x? What is it?
1 over x.
1 over x. Which, that now explains why that x is there. Because that x is there because it's part of the du. So du over square root of a squared minus u squared. That's definitely arcsine now. So I agree, it looked like arcsecant with that x sitting there, but when you started matching up a's and u's, that x was a result of du, not a result of arcsecant. So let's see, arcsine of u over a. Oh, and again, if I've labeled u and a, then I can just leave them as is and be good with that. Escalating our trickiness here. How about number 6? What does that look like? I got something squared plus something else squared. Which one does it look like? Arctangent. Because there's no square roots. So I'm pretty sure we're headed toward arctangent. So let's let u be x plus 3. And a can be 5. du is dx. So, yeah, this is, once you make the right u substitution, I guess. This is an easier one. Well, I don't know. I guess they're all easy. If you make the right u substitution, you always end up with something you recognize. So this was arctan of u over a. And again, I can leave it as u over a because I've said what u is and what a is. Although tangent has that extra a in there, so it needs the extra a out front. I haven't done one where I filled the stuff back in, so just to make sure we're okay with this. That's what the multiple choice answer would look like. That would be your safe stop answer. All right, 7 and 8. This is where the problems where you go from a 4 to a 5 on the AP test, because that does not look like any of our options. It also doesn't look like, right? So you kind of start thinking, well, what are my other options? If I let u be the denominator, then du is 2x plus 4. That doesn't do me any good. So that doesn't really work. This is one of those where your teacher has to show you what to do. Otherwise, like, who came up with this? Do you know what I'm about to do? What?
I said it to him a minute. Is it completing the square?
Yeah, it's completing the square.
He says complete the square.
Well, complete the square. Complete the square. Because if we complete the square, this one I can make it look like number 6. Sort of kind of where we're headed here. So let's see, complete the square. The main steps of complete the square are half it, square it, add it. Half it, square it, add it. Now, half of what, square what, add what? Half of what? That's our most important part there. Half of b. So b over 2, b is 4, is 2. If I square it, I get 4. So I'm going to put a plus 4 there. But I can't just go sticking plus 4s in places. That's not legal. So how could I kind of balance out the plus 4? Well, what's the opposite of adding 4? Subtracting 4. So I could subtract 4 like later in the same line. So I haven't changed anything. Sort of rearrange things. So all of that is x plus 2 squared. And 13 minus 4 is 9. And now it looks like exactly like number 6. So if u is x plus 2, a is 3, it's an arctan problem.
Sorry, I still have to take the final. And I need to do that today.
Okay.
So,
Alright, so yeah, this is an arctan problem exactly like number 6 after we did complete the square. So arctan u over a. Whoops, tangent has the extra a, so 1 over a out front. Plus c. I've said what u is and what a is, so I'm okay with that answer. Completing the square. How lovely. Number 8. X to the 4th in there. If I let u be the bottom, then du would be 4x cubed, so that I'm not even going to write that down. I can tell right away that that's not going to work. So hopefully you get quick enough where, yeah, you're going to false start on some u ticks, but hopefully you don't have to write them all down. If u is the denominator, du is no good. So I wonder if I could play complete the square again. This one's extra fun. I mean, I guess it's the same process. B over 2 is negative 3. So I'll add 9, which means I now need to subtract 9. So I've got x over, I can factor this now. That's always the point of completing the square, is that you can factor what you get. x squared minus 3 squared plus 4. Let's see. Okay, so that kind of looks like arctan, because I've got something squared plus 4. There's an x in the top, but this is supposed to be u squared plus a squared. So I could let u be x squared minus 3. du then is 2x dx. Oh, that explains where that x came from. So I'll spawn a 2 in there to make 2x and make all of that now du. I better say what a is so that if I leave a u and an a later on, I'm okay to do that. So 1/2 antiderivative du over u squared plus a squared. As always, the hard work comes up front. You get toward the end and you're like, oh, it's maybe not a simple integration, but an integration we should recognize. So the 1/2 is kind of just along for the ride here. Arctan of u over a, but tangent has the 1 over a out front, plus c. And now am I okay with this as an answer? Because I've said what u and a are, we're okay with that. Ooh, that's a little sloppy on my part. That should be an a. U in the top, a in the bottom. Ugh, yeah. Let's look at the worksheet, see if there's anything crazy on this worksheet. Or maybe we just kind of look through and see what we think it is. So like looking at number 1, what does number 1 look like? Arc sine. What's number 2 look like? Sine. This is a square root in there. How about number 3? I think that's sine again, because a would be 1 and u would be x plus 1. So that would be an arc sine problem. How about number 4? Arc sine. What is u going to be for number 4? T squared. And then I'd have a du and I'd go from there. But yeah, this is headed toward an arc sine problem. 5 and 6 look kind of similar. What do they look like? Arctangent. In fact, I don't know that there's any arcsecant on this page. I will make sure the test doesn't have any arcsecant. Let's throw out arcsecant. I'll make sure the test doesn't have any. If it does, I won't count them because I already made copies. Let's see. Do we need to do one with limits on it? Oh, let's do number 8. Number 8 looks interesting. And of course, when the math teacher says it looks interesting, it's not good. It's not interesting. It's just hard. Thoughts on what number 8 looks like? I mean, there's no square root involved, so it's not sine or secant. So maybe it's tangent. If it's tangent, then that needs to be u squared and a squared. So a equals 1. That's an easy one. What would u need to be? If I want u squared to be e to the 2x, then what would u need to be? Yeah. If I square e to the x, I would get e to the 2x. And du then is e to the x, which is great because that's what's in the top. So I've got antiderivative of du over u squared plus a squared. I've intentionally left those limits, boundaries blank because I'm in the process of switching to u. So I need to switch my limits to u limits. So if x is natural log 5, U then is e to the natural log of 5. You know what e to the natural log of 5 is? Sounds terrible. It is related to the fishhook. E and natural log cancel each other out. So the answer is 5. All right, so 5 is my top limit. For my bottom limit, u equals e to the 0. Oh, that's a much easier one to deal with. That would be 1. So arctangent of u over a, with the 1 over a out front, from 1 to 5. A is 1, so that made this problem a little bit easier anyway. So arctan top limit minus arctan of the bottom limit, and that's a safe stop. I have no idea what arctan of 5 is. I do know what arctan of 1 is, but it's not calculus, so I'm just going to leave it alone. It's pi over 4, but I don't care. Correct. Because if you did have a plus c in there, you would, and you plugged in 5, you'd have, maybe we should do this in pencil. Don't write this down. So if there was a plus c in here, then you'd have arctan of 5 plus c, and you'd have minus arctan of 1 plus c, and so you'd have a plus c and a minus c, and they go away. So I guess it wouldn't be wrong to include it, as long as you were careful and included it all the way and then eventually canceled it out.
What happens to the 1 over a?
Oh, well, for this problem only, with a is 1, I didn't have to worry about it. It wouldn't have been wrong if I had left it, since I've declared what a is, if I had left this as 1 over a out there, that would not be wrong. That would still be accurate, because you said the a is 1, so this is an accurate answer, with or without the 1 over a. 9 looks like, what's 9 look like? Complete the square. What's 10 look like? E squared minus u squared, so that's arc sine. You'll have some du stuff going on with that one, so you'll have to do some spawning and moving that 7 out probably. Yeah, there's no arcsecants on here. It's all arcsines and arctangents. And you'll never have to get arc cosine and arc cotangent. Do you remember how those were related? They were only off by a sign. And so if you're going backwards, you just stick the negative sign out front, and you'll never have one of those as an answer. All of your answers will be either arctangent or arcsine. All of those answers are either arctangent answers or arcsine answers. Okay. Strongly encourage you to start some of worksheet 7, because worksheet 7 is where we throw them all into the mixing bowl, turn on the blender, pick one out, and then be like, oh, which one is that? So there's lots, probably all of them are U substitution, but there's just a bunch of, is there anything in there that strikes me as, what are we going to do on number 8? What's that? Algebra first. I would say number 12 is a bit of a trick, so I'd skip that one for now if you're going to jump ahead. Yeah, I would take a look at some of them, especially since it's a long weekend. That way you're not coming back and reviewing one day and testing the next day. I would definitely look at some of Worksheet 7. So officially today's assignment is Worksheet 6, but unofficially with the long weekend and with the test coming, I would look and attempt some of those mixed integration problems, and then we'll, whatever day we come back, we'll go over Worksheet 6 and Worksheet 7, and then we'll test the next day. So, yes, the next time I see you, we'll review, and then the day after that, we'll test. I'm kind of mixed. Do I want that to be on Tuesday, or do I want an off day? Yeah. Off days are kind of fun, especially if there's snow on the ground.